Alright, now, so this is part 2. Welcome back. Now, in the previous part, we talked about HCF and LCM on numbers, on integers. Now, we can do that for expressions, for variables as well. Say, for example, we want to find the HCF and LCM between a squared BC and AB squared, for example. Alright, now instead of numbers, we have A's and B's. But the idea is almost the same, right? Only that we know that A's and B's they do not have a common factor. They do not mix. All right. So once again, we line them up in columns like this. So we have A square, B C. On the other side, we have at the lower row we have A B square. All right. The things I didn't put in, they would be power 1 and power 0. Right? Power 0. So for the HCF highest common factor, we choose the opposite. We choose the smallest power in each column. So in this A column, we have power 2, power 1, we choose 1. On the B column, we choose 1. On the C column, we choose 0. So that for the HCF, you have A first power, B first power, and C 0 power. So AB is the HCF. Now as for the LCM, we choose the highest power on each column. So A we choose 2, B we choose 2, C we choose 1. So we have A square, B square, C. Now that would be the LCM. That would be the LCM. Alright, so it's very similar to what we did for integers, only that we have letters to replace the numbers. Now you can apply the same idea when there are 3 numbers altogether. Say we got 3 numbers, P square R, P square R, right? We have P cube, Q cube, and R square, alright? We have P, Q square, R cube. So we got 3 numbers, right? One of them is P square R, the other one is P cube, Q cube, R square. The third one is P Q square R cube, right? 3 numbers. And then to find the HCF, once again, we look for the smallest power in each column. Alright. Now, if you are not familiar with it, I suggest you put back the missing stuff. A single P actually is P to the first power. Alright. A single R is R to the first power. Now, this blank here is the most confusing. A lot of the people, they were making mistakes when there is a blank position. Alright. It should be Q to the power 0. It should be a 1. Alright, it should be a 1. So that when you make the decision, when you make the choice, you won't miss the 0th power. That is a Q to the 0th power. Now, what I put back in red, those are the hidden, those are the missing item, right? If you are familiar with it, you can skip it. But if you are not familiar with it, maybe it is a better idea that you put back those red ones. Alright, so highest common factor, highest, we choose the smallest power. So we choose this 1, 0, and 1. Alright. So the highest common factor will be P, no Q. The Q to the power 0 is a 1, alright? And R. So this is it. PR is the highest common factor. For the lowest common multiple, LCM, we choose the highest in each column. So we choose the 3 here, the 3 here, and the 3 here. So that would be a P, we have the P cube, Q cube, R cube as the least common multiple. Alright, so that is for variables A, B, C, and P, Q, R. If there is a pair of numbers or if there are 3 numbers, it works the same. Alright. So that's pretty much cover the basic idea for HCF and LCM. Now, there are 2 common question types, or there are two variations. Right? I would want to remind you. Say variation number 1. When there is a leading coefficient. When there is a coefficient. Now, for example, when you want to find the HCF and LCM between these 2 numbers, 12 A squared BC and 18 AC squared. Alright, we want to find the HCF and LCM between these 2 numbers, 12 A squared BC and 18 AC squared. So now, like previously, we try to put them into columns. So there's 12, there's an A, there's a BOA square, there's a BC, alright, and then there's an 18, there's an A, that is a C square. Alright, so you put back the missing power. There's a 1, there's a 0, a 1, there's a 1. Alright, so there's 12 to the power 1, 18 to the power 1, 18 to the power 0, 12 to the power 0, right? So this is how we put down the numbers into respective columns. Oh, but wait. Don't do that. It's wrong. It's terribly wrong. Alright. Because when you have coefficients, when the number 12 and 8, you have to break them down into prime factors as well. What I just did is a poor demonstration. We should have broke down the 12 and 18 into the prime factors as well. Now 12 will be broken down into 2 square times 3. 18 will be broken down into 2 times 3 square. Alright, so these are the prime factorization. You break down 12 and 18 into prime numbers. So the first number will be broken down into 2 square 3 A square BC. Alright. And for the second number, that would be 2 times 3 square AC square. Alright. To put down the missing power, we have this. Oh, this is not a 0, it's a 1. Alright, to put back the missing power. And then from here, we can try to find the HCF and the LCM. The HCF, you choose the smallest power, will be 2, 3, A, no B, and C. Alright, 2 times 3. So that is 6AC will be the highest common factor. For the LCM, you choose the highest power in each column. So 2 square, 3 square, A square, BC square. Alright, so that would be 36 A square BC square. Alright, so this is the first variation. Alright, the second variation, variation 2. Now that was the first variation. When you have a constant like 12 and 18, you have to break down those numbers into prime as well. Alright, now the second variation. The second variation is that sometimes you have to do the factorization beforehand, factorize beforehand. Alright. Now take a look at this one. For example, if you want to find the HCF and LCM between x squared minus y squared and x minus y all squared, they look similar but they are not the same. Alright. So you cannot align them into columns because x squared minus y squared is not yet factorized. So I think the best way is to factorize this into x minus y, x plus y. So 2 distinct factors. And then x minus y square will be this one. Alright. So the 2 numbers, they are like that. So now it comes back to the original idea. The HCF, we pick the smallest, highest common factor. We pick the smallest power. Alright. There is a missing power 1, and there's x plus y will be power 0. Right? When nothing there, you choose power 0. So the HCF will be simply the x minus y. Alright, and this one. No, so that is the HCF. As for the LCM, we choose the highest power in each case. So that would be x minus y all square, x plus y. That would be the LCM. So this is it. That would be the thing on HCF and LCM. Now, I believe there's an assignment that you have to do after that. Alright, now for the assignment, it will be posted separately. Alright. So this is the end.